Okay, I'd like to begin the lecture today with this image here. This is a rather iconic image that was taken by the Apollo 8 astronauts back in the 1960s. On their first orbit around the moon and coming from the dark side of the moon, they came around and they saw this rather startling image, and it really speaks to us about perspective. And when looking at natural resource management, perspective is a very important consideration. Now, many of you probably have seen this image that rotated 90 degrees with the horizon on the horizontal, but this is actually the original format that this image was taken in. Now, it's very hard to understate the importance that this image has had, not only to the Apollo 8 astronauts on board this spacecraft, but as this image was brought back to Earth. For the first time, humans saw the Earth from this perspective. As a matter of fact, the first time any terrestrial organism has seen the Earth from this perspective. And whereas when you're on the surface of the Earth seems almost limitless in its ability to provide us with raw materials, boundless in its ability to process our waste products, and limitless in its ability to provide us what we need to sustain ourselves. Especially when you think about it, you know, the vast oceans that cover the Earth, the great land masses. When you look from horizon to horizon, that mindset of a limitless ecosystem is one that's pretty typical. However, seen from this perspective, the Apollo 8 astronauts instantly recognized a different reality. And that was that, as they had described it, the Earth looked like a small blue marble hovering in the vast emptiness of space. And as such, they saw us, the Earth as limited and isolated. And for those reasons, they became very environmentally aware, as did many humans when they first saw this image. So perspective, again, is a very important consideration when you think about the fact that this is it, that there's no place else to go, that we have to get this right, we have to manage these resources for at least the foreseeable future. This is our only source of raw materials, of natural resources, and so on. This other image here is a satellite mosaic showing half of the Earth as well, and again, perspective being the all-important consideration in this case. Like I say, this is not a rehearsal. There are no do-overs. When you think about every human, all 7 billion of us are sharing this planet, along with the members of upwards of 50 million different species, all gathering our raw materials, our natural resources, and having our wastes processed, all in this one area. You know, going back to the image, the Apollo image, one of the astronauts was very struck by the fact that he could raise his thumb and block out the Earth, you know, the area that he had, you know, had all of his experiences, all of his memories, his family and everything, his entire experience on this one planet. And again, the point here is that there is no other alternative, that we have to be able to manage these resources in the long term so that they're here for us, they're here for future generations, and for all the other organisms that share this planet. And that takes management. That takes careful consideration. Okay, I'm going to start with some basic concepts here, and most of these concepts you're going to see that I start with a series of definitions. Now, most of these terms are actually pretty straightforward. You know, you have a good working knowledge of these topics, but I wanted to go ahead and define these terms so that when we use them here in class, we're all talking about the same thing. The first term here is environment, and that comes from a French root word which means to encircle or to surround. So the environment then, of course, would be our surroundings. Another definition I want to cover here is science. And science is a process of study, but more precisely, it's a systematic, precise, and objective process of study. Systematic means that to run a viable scientific experiment, you have to follow rules and steps and procedures. That's the systematic part of it. Precise refers to the fact that if I repeat my experiment or somebody else repeats my experiment, they should come up with basically the same results. And finally, probably the most important term here is objective. Scientists must be objective. They must go into an experiment with an open mind and be willing to follow the data. Even if they have kind of a pet hypothesis, or they are convinced of a certain outcome, and the data that they actually collect is not in keeping with this, a scientist has no choice but to either come up with another hypothesis or to modify their theories. So objectivity is a very, very crucial part of the scientific process.